Good morning, class. We are looking at College Algebra Chapter 3 Functions, Section 3.2 Domain and Range. Domain and range. Chapter 3 covers Section 3.1 Functions and Function Notation, Domain and Range, Rates of Change and Behavior of Graphs, Composition of Functions, Transformation of Functions, Absolute Value Functions, Inverse Functions. Section 3.2 Objectives. Find the domain of a function defined by an equation graph piecewise defined function. Reminding you of the following functions and function notation. Dependent and independent variables. For an equation in variable x and y, if the value of y depends on the value of x, then y is the dependent variable and x is the independent variable. Relation, a set of ordered pairs. Domain, the set of all input values. X values, also known as independent variable for a relation. Range, the set of all output values. Y values, also known as dependent variable for a relation. So as we look at this graph, along the x-axis, it covers from here to here. It's known as the domain. Along the y-axis, it covers from here to here. So the bottom of the graph of the function, the top of the graph of the function, and this would be the range. Function. A function is a relation in which each element in the domain corresponds to exactly one element in the range. We can check it out, and the difference quotient should dq, which is really rise over run, f of x plus h minus f of x over h, as h, and h can't be zero. As always, when you're looking at a fraction, the denominator can't be zero. To recognize a function, a graph, we use what's called a VLT, vertical line test. If a vertical line can be drawn so that it intersects a graph at more than one point, then the graph does not represent a function. If a vertical line cannot be drawn so that it intersects a graph at more than one point, then the graph represents a function. In short, what is a function? The first variable, the x value, the independent variable, cannot repeat. And one way to check it is through vertical line test. A function is one-to-one if each element in the range corresponds to exactly one element in the domain. Horizontal line test. If a horizontal line can be drawn so that it intersects the graph of a function at more than one point, the graph is not a one-to-one function. So, in the case of a function, the x coordinates cannot repeat. In the case of a one-to-one function, now the y coordinates cannot repeat either. So we use VLT, or vertical line test, to check a function. We use HLT, or horizontal line test, to check, to make sure it's a one-to-one function. Here's the library of functions. The summary. The constant function f of x over y equals b. B is a real number. Looks like this. So y, or f of x equals b, it has a y-intercept at 0, b. There is no x-intercept. The domain is all real numbers from negative to positive infinity. Okay, this covers the x-axis. But it covers only one point along the y-axis. Therefore, the point B, and we use braces to represent one point. Y or f of x equals x is a line that goes through the origin. Domain and range are both all real numbers from negative to positive infinity. So it covers the entire x-axis. If you were to lay it down on the x-axis, if you were to lay it down along the y-axis, it covers the entire y-axis. Square function, or f of x equals x squared, a parabola looks like that, with the cube function looking like this, and the domain is all real numbers here. This side covers the right side, and this side covers the left side of the x-axis. And the range from here up, 0 to infinity. In this case, for a cube function, domain and range are all real numbers from negative to positive infinity in both cases. Square root function, y or f of x equals square root of x, looks like this, whereas y or f of x equals cube root of x looks like this. By picking up a bunch of pairs, we can see that, and then they become library of functions, elementary functions, essential functions that we are supposed to know the graph for the sake of transformation. So as you can see here, the domain and range, domain goes from 0 to infinity, so does the range. So the domain 0 to infinity, range is 0 to infinity, and 0 is included. Cube root of x, just like y equals x cubed, the domain and range are all real numbers. The reciprocal function, f of x equals 1 over x, looking like that, it covers everything along the x-axis except the 0, because we have a vertical asymptote as well as a horizontal asymptote. We discuss it further later on. And it doesn't cover 0. The same thing for the y. So in both cases, all real numbers except 0. So how do we write that in an interval notation format? Domain. D stands for domain. From negative infinity to 0, union 0 to infinity. R stands for the range. From negative infinity to 0, union 0 to infinity. So it's pretty straightforward, everybody. Domain and range. Domain, the set of all input values, x values, independent variable for a relation. Range, the set of all output values, y values, dependent variable for a relation. So if this is the case, we have a solid point here, solid point, the endpoints are included. So imagine if you were to put this along the x-axis, what portion of the x-axis will it cover? From here to here, that's the domain. Imagine if you could put it along the y-axis, what portion of the y-axis will it cover from here to here? That's the range. So as far as understanding the concept of the functional value, so if this is 1 and this is the y coordinate for that, this distance is f of 1. So this point has coordinates 1, f of 1. This one, this coordinate would have a coordinate 2, f of 2. As you can see, in general, if you have x, this distance is f of x, or y corresponding to this x. So x, comma, f of x. So here's the first example. The graph of a function f is shown. Find the value of f of 1 and f of 5. So that means locate the 1 along the x-axis and find the point on the graph. And that point has coordinates 1, 3. Therefore, the answer is for f of 1, 3. We are reading the graph, so we want f of 5. Locate 5 1, 2, 3, 4, 5 on the x-axis, representing this point, and this point has a y coordinate which is roughly negative 0.7, negative 0.7, whatever that you read here. So negative 0.7. What about the domain and range? Well, this graph covers anywhere from here to here along the x-axis. So if you were to lay it down along the x-axis, it can cover from 0 to 1, 2, 3, 4, 5, 6, 7. So the domain is 0 to 7. If you were to lay it down along the y-axis, as you can see, the bottom is here, the top is here, so it will cover somewhere from here, negative 2, to here, positive 4. So we say the range is y such that y is between negative 2 to 4, or just the interval notation from negative 2 to 4. How you represent that, it's up to you, everybody. Okay, both, if they ask for the interval notation, that would be the answer. Okay, again, pretty straightforward. Interval notation makes it, I think, pretty easy to understand. Example 2, for the function f represented below, determine each of the following. Part A, what member of the range is paired with negative 2? So you look at negative 2, you look at the point, and this point, as you can see, has coordinates negative 2, 3. So it's negative 2, 3. This is the pair, so you could answer it in this format. If you just said 3, it's just correct. They may just want you the y coordinate to write the y coordinate. I wanted to emphasize the location. Domain, what is the domain? So if you were to lay this down along the x-axis, the left side will cover this point, about negative 5, and the right side will cover this point 3. So you can write it in this format. X such that x is between negative 5 and 3, so minus 5 less than or equal to x less than or equal to 3. Or you can go with the interval notation. Either way is fine, everybody. What member of the domain is paired with the 6? So that means along the y-axis, you have to locate number 6. Along the y-axis, we locate number 6. And we find the point. And this point seems to correspond to roughly 2.5. So again, it may not be exact. So it corresponds to 2.5. So it gives us the pair 2.5, comma 6. And y equals 6 corresponds to x equals 2.5. So we can write it in this fashion, that x equals 2.5. So in fact, let's just get rid of that. What about the range of f? If we lay this down along the y-axis, the bottom seem to be covering -1, the top seem to be covering 7. So we can write from -1 to 7. So y such that -1 is less than or equal to y less than or equal to 7. If I were to write an interval notation, I could write it as -1, comma 7, both of them in a bracket because the endpoints are included. Now, the reason sometimes they like this method better because if you just write the interval notation, one may not know which one is the domain, which one is the range. Clearly, this X represents the domain, this Y represents the range. That's why. But you need to understand in what format they're asking you to write it, and you do so accordingly. Finding the domain of a function defined by an equation. How do we do that? Number one, start with the domain as the set of real numbers. In other words, consider all real numbers to be the domain, and then start excluding if need be. How? Number two, if the equation has a denominator, exclude any number that give a zero denominator. So any numbers that result in 0 as far as the denominator is concerned. If the equation has a radical of even index, exclude any numbers that cause the expression inside the radical to be negative. Notice two things that you want to exclude. If you have a fractional format, you set the denominator equal to 0 and exclude it. That's the second part. If you have a radical format, if the index is odd, you have nothing to worry about. If it's even, has to be non-negative, what's inside the radical sign. So here's a warm-up example. If you look at the first one, g of x equals x squared minus 9. If you look at the second one, cube root of x minus 1. What is the domain? It's all real numbers. Why is that? This is considered, as you recall, a polynomial. Polynomial of degree 2. Any polynomial has a domain that is all real numbers. So what is a polynomial in general? Let me write it here. A polynomial p of x is a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 all the way to a sub 0, where a sub 0 all the way to a sub n, they all are integers. And as you recall, integers means 1, 2, 3 to infinity, -1. I mean the exponents. Are real numbers. My apologies, class here. These are real numbers. Real numbers, okay. Real numbers. And the exponents, all exponents that means n n minus 1 all the way, of course, to 0, because this last one, has x to the power of 0. They are all whole numbers. Okay? That's why, for example, x to the power of 1/2 or 2/3, or if you have a fractional format, it's not a polynomial. So this is a polynomial of degree 2. And all polynomials have a domain which is all real numbers. What about this one? If you go back here, a radical of even index, the index is odd. It's an odd number, everybody. Okay. So pretty straightforward. We want to find the domain of each function. The first function, f of x, equals x plus 4 over x squared minus 2x minus 3. It's a fractional format. More precisely, it's a rational function. A rational function is a function where the top and the bottom are both polynomials. As you recall, the process is very simple. Set the denominator equal to 0 and exclude that. To do so, we are going to factor this into x minus 3x plus 1, because on two numbers, the product is -3 and the sum is -2. So set this equal to 0 by factoring. X is either 3 or -1. So this says x is 3. This one, x, let me just write equals 1. So when you set the denominator equal to 0, this is what you get. What is the domain? X can't be 3. This was -1. I mentioned it on that. This is negative. So all real numbers except 3 and -1. So you can write it in this format, x such that x is not equal to 3, x is not equal to -1. But the interval notation is written in the following manner: minus infinity comma -1, union -1 to 3, union 3 to infinity. Notice for -1 and 3, we all use parentheses, which means we are excluding the endpoints -1 and 3. So that's one format. The restriction is, again, set the denominator equal to 0, exclude that. This one, notice when we don't write the index is 2, the index is even, therefore 3 minus 2x greater than or equal to 0. So we move the 3, we make a -3 on the right side, divide both sides by -2, so we get x, and the sign will flip over. Greater than or equal changes to less than or equal. -3 over -2 is +3/2. So x is less than or equal to 3/2. So this is the inequality format, and this is the interval format from -infinity to 3/2. What about 3/2? Because we have the equality, it takes a bracket. F of x equals square root of x plus 3 over x minus 4. Well, the top part, x plus 3, must be larger than equal to 0 because the index is missing, means the index is 2. And the bottom one says x cannot be 4, right? X minus 4 equal to 0. X cannot be 4. So let's write them together. On the one hand, x plus 3 must be larger than or equal to 0. On the other hand, x can't be 4. So if you stick with that only, it means x is larger than or equal to minus 3, and it means from minus 3 to infinity. So here's what you do, and this is not, of course, finished. You look at this one. If it's in this interval, you're going to exclude that. If it's not, just ignore it. Let's say instead of x is not equal to 4, let's say it was negative 4. If it were negative 4, we would have nothing to worry about, but it's not. 4 is in between. So we get rid of it. How? This way. We say from negative 3 to 4, union 4 to infinity. Negative 3 endpoint is included, but 4 is not included. We use parentheses. So this becomes the answer. Again, I believe it's pretty straightforward, everybody. Given the function f of x equals x over x plus 1, is the point 1 comma 1 half, the pair of 1 comma 1 half, on the graph of this function f of x? You just plug it. Meaning what? Just plug in 1. If the result is 1 half, the answer is yes. If it's anything else, the answer is no. So let's evaluate f of 1. When we do that, it's 1 over 2. That's correct. The answer is yes. When x equals 2, what is f of x? And then write it as a point, as a pair. So basically, class, plug in 2. Plug in 2. So we get 2 over 2 plus 1. We get 2/3. What does it mean? The pair with coordinates 2 comma 2/3 is on the graph of the function f of x equals x over x plus 1. F of x equals 2. That means the y coordinate in essence is 2. What is x and what is the point? Well, set f of x, x over x plus 1 equals 2, and solve for x. And to do so, we do the cross product. 2 times x plus 1 equals 1 times x. When we distribute, we get 2x plus 2 on the left side. We move things around. And we get x equals minus 2. So the pair x comma y, x comma y, so has the coordinates negative 2, y or f of x is 2. So that's the pair. Pretty straightforward, everybody. Graph piecewise defined functions. Sketch the graph of the function f of x equals 2x minus 3 times the absolute value of x. First, I want to remind you about the absolute value of x. You remember its distance from 0. Therefore, absolute value of x is x if x is greater than or equal to 0. Absolute value of x is minus x if x is less than 0. To make some sense out of this, so see how that works, because sometimes students get confused. If I give you 5, so it puts us here, everybody. It says drop the absolute value. But if I ask you to come up with absolute value of -5, it puts us here. It says drop the absolute value and put a negative in front of it. Remember, x is -5 here. So, and what minus x means is the opposite of this number. So this means if x is negative, right, it's opposite. So minus x doesn't mean a negative value. Minus x means the opposite of whatever x is. In fact, because x is negative, its opposite is positive. So write the opposite of -5, minus 5, and that is equal to +5. That's the meaning of absolute value. I wanted to mention it here because I've seen students sometimes making a mistake. With that being the case, let's look at this one. If x is positive, just drop the absolute value, make it 2x minus 3x. If x is greater than or equal to 0, 2x minus 3x or minus x. However, if x is negative, then 2x minus 3 times, remember, you're going to replace this with minus x, which makes it plus, so 2x plus 3x makes it 5x. So I hope this concept and this will help you see what's going on here. Okay, let me erase actually this so it becomes clear. This absolute value of x, you drop the absolute value sign if x is greater than or equal to 0. This absolute value of x is replaced by a negative if x is less than 0. In essence, you just change the x, so -3 remains actually outside. So it may be better that you leave it in this manner. You keep the -3 outside and you just change this to minus x. That's the concept. Not that it changes anything. What is 2x minus 3x? Minus x. What is 2x minus 3 times minus x? That means plus 3x. That means 5x. So now these are the two pieces of the puzzle. F of x on the one hand is minus x, on the other hand is 5x. So how do I graph piecewise defined function? First, I'm going to graph each piece separately without paying any attention to the restriction. So I'm going to graph f of x or y equals minus x. As you know, looks like that. It goes through the origin. You can put 0, 0, and then 1, -1. Graph that. I'm going to graph this piece. Again, never mind what it says here. F of x or y equals 5x. It's a graph that goes through the origin this way. It goes through 0, 0, and if x is 1, y is 5. So you graph those. First, we want to look at it that way, okay? Now, we are going to put them together. Now we're going to pay attention to what's given. It says f of x equals minus x if x is less than or equal to 0 with the equality. That means this portion is okay, this portion is not. In other words, here's this portion is out, everybody. So the answer is this part, including this. So you keep this part. For this part, f of x or y equals 5x. This is when x is less than 0. That means this part is out. The other part is the solution. This is the solution. And there is a hole here. So again, this means this portion and 0, 0 is included. This means this portion and 0, 0 is not included because we don't have the equality. When we put these two together, minus x, over here is the other way around. My apologies for this one, everybody. So let me. This portion is out. This portion is the graph with this being a solid point because of the equality. So let me go over that one more time. So f of x of y equals minus x if x is larger than or equal to 0. So larger than or equal to 0 is acceptable. This portion is not. My apologies. So pay attention to this one more time. Y equals minus x is this one. This portion is not acceptable because x must be larger than or equal to 0. This portion is. And the end point 0 is also acceptable. When we look at this one, this is when x is less than 0. This side. So this is acceptable. This is not. Because it doesn't have the equality, this takes a hold. However, when we put these two together, this covers this one. It's important. It's part of the upper piece, not the bottom, the bottom piece. But they come together and they look like this. This one and this one will give us this graph. Graph piecewise defined function. Sketch the graph of the function f of x. Evaluate a few points and determine the domain and range. As far as evaluating a few points, let's first do that. Then I want to show you again how we graph them piece by piece and then put them together. So, for example, if we pick those points, let's see how we do the evaluation. Minus 1. Pay attention to the fact that f of x or y equals minus x plus 1. When x is between these two numbers, between -1 and 1, -1 is included, 1 is not. At precisely x equals 1, we have the y coordinate 2. So right away, this means, everybody, this means 2 here. Look at this one. This means 1 is 2. So the pair is 1, 2. And this says f of x takes the function x squared when x is larger than 1. So let's start with -1. -1 is included here. So if I put a -1 here, I get minus -1, which makes it positive 1, and 1 is 2. If I want to put 0, it's between -1 and 1, so I'm going to put it here again. And 0 gives me 0 plus 1, 1. 1. It's not here. I mentioned that 1 is 2. Okay, 1 is here. Okay, 2. 2, x larger than 1 goes here. 2 squared is 4. 3 squared is 9. And we get those. Just in case if we were to evaluate a few points, and honestly, if you put a few more points, you can graph it. Just for the sake of argument, less than -1, if you pick a number less than -1, let's say -2, it's not defined there. So what is the value for -2? It's not given because this goes from -1 to 1, and beyond -1 on the left, we don't have any piece. So we have 3 pieces, and we don't have anything that defines. But in any event, let's see how we graph it. We are going to graph y equals minus x plus 1 without paying any attention to the pieces. Then we put them together. So y equals minus x plus 1. I hope you see that you can put, obviously 0, 1 is the y-intercept. And if you choose x to be 1, you get 0. So you have those two pairs, 0, 1. This is 2, so 1 is in between. This is 2, so 1 is in between. And that's the graph. Okay, so this is the first one. Again, we are going to pay attention to the limitation later on, to the restrictions. Then we have the pair 1, 2, this one. The pair or the point 1, 2. Then y or f of x equals x squared is a parabola. You know that, right? Now, so we have 1, 2, 3 pieces. Of course, the second piece is just a point. Which portion of each graph is acceptable? Let's look at the restriction that they give us. Starting with this one, this line, which portion can we use? It says you can use it from -1 to 1. So -1 is here. I'm looking at the graph. -1 is here and the point is here. So over here we have a point which is included because of the equality. So that one is good. All the way to 1, you locate the 1. The 1 is here, right? 1, 0, and that takes a hold. So this portion, this is a solid point, this is a hold. This is a solid point because of the equality. This is a hold because we don't have the equality. This one is very straightforward. There's only one point there. The point with coordinates 1, 2. Now let's look at the parabola, which will see which part will work and which part will not. It says we can use the parabola as long as x is larger than 1. So this parabola, when x is 1, we are here. And it says it's good when x is larger than 1. So from here on, what about this point? We don't have the equality. So at x equals 1, which is 1, so that means 1, 1, there is a hole here, everybody. There is a hole here because we don't have equality, and it goes up. So to put them together, it looks like this. This portion, there is a hole. This portion, there is a hole. And this point is here. Now let's look at the domain and range. Actually, right here, it tells you the domain is from -1, -1 is included, all the way to infinity. What about the range? Notice the range is from the bottom here all the way to infinity, but is 0 included? We have a hole here, so 0 is not included. So which portion of the y-axis is covered? The positive side, and 0 is not included. So the range goes from 0 to infinity, and 0 takes a parenthesis because it's not included. Find h of minus 5 when h of x is defined as x plus 4 is if x is larger than or equal to minus 4, and h of x equals minus x plus 4 if x is less than minus 4. And we claim h of minus 5 is 1. We want to see why is that. It says when x is less than negative 4, clearly minus 5 is less than negative 4, use this one. So we're going to plug it into this one. Minus minus 5 plus 4 equals minus negative 1 equals 1. Okay. We continue with piecewise defined functions. We want to graph f of x and find its domain and range, where f of x is defined as an absolute value of x when x is between negative 3 and 1, and then cube root of x if x is larger than or equal to 1. So we're going to do the same thing. That means we are going to graph each piece and then put them together. So first, absolute value of x. So y equals absolute value of x. It's a V shape, and it looks like that. Cube root of x, y equals cube root of x, looks like this. Okay. Now we're going to go and pay attention to this restriction. This says it's good from negative 3 to positive 1. So negative 3 is here, and 1 is here. Now, is negative 3 included? Yes, so you get a solid point here. Is positive 1 included? No, you get a hole here. Okay, so if we put them together, looks like that. We are going to see which portion. So we need a solid point here. We have a hole here, so this portion. So from here to here to here, and there is a hole here. What about this one? When x is greater than or equal to 1. First of all, if you put 1, you get 1. By the way, it's important to know the coordinates of these points. So let me write that this one has coordinates negative 3, positive 3. This hole, and this is a hole, has coordinates 1 and 1. And now what happens is from 1, including 1, to infinity, we use this function. So we look at 1 and we locate 1, 1 and everything to the right of it. So this has coordinates 1, 1. So I want to make sure we understand what's happening. So we have this portion from the absolute value function, this portion from the absolute value function, from the cube root function. There is a hole here at 1, 1. There is a solid point at 1, 1. So this will cover this one, but it comes from the second piece. So what we have is, in essence, let me show you on this one, and then I'll separate that. Let me see what color I want to use. Let's use this color. So we locate negative 3, 3 here. And by the way, this one becomes a solid. So this portion is covered. Okay, this portion is covered. Both of these pieces are from the absolute value. This point is a whole from the absolute value point of view, and it's solid from the point of view of a cube root, so they come together. So this is covered, and this portion is covered, and looks like this. So, therefore, what is the domain? Well, the domain is all real numbers, except it stops at here or at here. So from -3 to infinity. So because to the left of -3, nothing is defined. So the domain starts from -3, including -3, and goes to infinity. But what about the range? As you look at this result or this result, everything that is on the positive side of y. How about 0? 0 is also included. So the range is from 0 to infinity. So this means this class bracket. So there's a bracket here, everybody. If it's hard to see, bracket 0 to infinity. So again, sometimes they use the inequality because they want to make sure that everybody understands. In the first case, it means x is larger than or equal to -3. That's for the domain. For the range, y is greater than or equal to 0. Okay, that's why sometimes they use the inequality so the reader can see which one is x, which one is y. We're going to continue with the piecewise defined function. Graph the following piecewise defined function. F of x is 3 if x is less than or equal to 0, and it's minus x if x is between 0 and 1. 0 is not included, 1 is included. So in short, we graph the first one, y equals 3, which is a horizontal line, and y equals minus x, which is a line that goes through the origin. So this is y equals 3. This is y equals minus x. Now we're going to put them together by looking at the restriction. Let's see how this thing is going to work. It says f of x is 3 as long as x is less than or equal to 0. So it's this line, as long as it's less than or equal to 0, to the left of 0. So there is a solid point here and everything on this side. So that's what it means. What about y equals minus x? Well, when it's between 0 and 1, so 0 is not included because we don't have equality. 1 is included. 1, 1. This point has coordinates 1, 1. 1, -1. So this one has coordinates 1, -1. This one has coordinates 0, 3. And to separate that, to be clear, there is a solid point, goes to negative infinity. There is a hole and goes this way, all the way to 1, -1. And that's the graph. Example 10, obtain information about the graph of a function. Here's the graph that is given. The very first question is, what is f of 0? When x is 0, what is the y coordinate? And I hope you see we are referring to this point, right? To this point, which has coordinate 0, 4, so the answer is 4. Domain and range. Domain, if you lay this along the x-axis, this covers this one, this covers this one, and so it goes anywhere from 0 to this point. The y coordinate for this point, 4 pi. Okay. What about the range? The bottom is here, the top is here. The range is this much from -4 to +4. So again, I'm showing both ways. Again, I want to emphasize, sometimes they put it in this format so the reader can see when we say 0 to 4 pi, one may be confused as to whether we are referring to x or y. So sometimes they write it in this format, x such that x is between 0 and 4 pi, both of them, the endpoints are included, or bracket 0, bracket 4 pi, 4 pi close bracket. For the y is between -4 and 4 and endpoints included, bracket -4, comma 4, close bracket. Intercepts. Well, the y-intercept is at 0, 4. And then the x-intercepts are these 4. Let's just plug in those 4. So the intercepts, first the y is 0, 4. Now the x-intercepts power to 0, 3 power to 0, 5 power to 0, 7 power to 0. This is in trigonometry. Okay, this is a cosine function, by the way. Graph of cosine function from 0 to 4 pi. How often the graph intersects the line y equals 2? Y equals 2 is a horizontal line. You graph it. Here's number 2. Here's the y equals 2. As you can see, it crosses it at 1, 2, 3, 4. Maybe what color do I want to use? So there is one place here, one place here, one place here, one place here, total of 4. So 4 times. F of x equals -4. So the y coordinate is -4, everybody. This point has coordinates pi, comma -4. This point has coordinates 3 pi, -4. So there are 2 places. X is either pi or 3 pi. This point, pi, as well as 3 pi. F of x is larger than 0. What is the x value? Where is the function above the x-axis? That's the meaning of f of x larger than 0. So notice, see if I can use some colors here that will help. Let's go with green. This portion is above the x-axis. So from 0 to pi over 2, but pi over 2 is not included. This portion of the graph, maybe if I make it red, it's easier to see. Let me just actually clean it up and go with the red. So this portion of the graph is above the x-axis. This portion of the graph is above the x-axis. This portion of the graph is above the x-axis. So please understand, for example, here, you say from 0 to here, pi over 2. Okay, 0 is included, yes. clearly is above. Pi over 2, no, because we want it to be greater than 0. Then from here to here is from 3 pi over 2 to 5 pi over 2, and 3 pi over 2 and 5 pi over 2, they take parentheses, they are not included. From 7 pi over 2 to here, 4 pi. Is 4 pi included? Yes, it's above. But is 7 pi over 2 included? No. So we write 0 to pi over 2. 0 is included, pi over 2 is not. Union. 3 pi over 2 to 5 pi over 2. None of them is included. 7 pi over 2 is not included. 4 pi is included. Union 7 pi over 2 to 4 pi.